So we should have the message open, update, and the others. All right. And also we have the other messages, keep alive or notification, just for your reference. Indeed, if we want to have the messages change, we need to have all of the details. But I just don't know, yes, we have the advertisement, and maybe you can pass on the possible message to have the full message exchange procedure. All right, so in fact, we will use them, but we just emphasize the concept how we have the advertisement. All right, so let us continue. And previously we have the prefix one. All right, so prefix, then we can allow the other autonomous system to know the path advertisement. All right, so here these are the recall. I assume you know all these. So if we have the advertisement, then we want to know the forwarding table. Which one you want to reach? Destination 1C. All right, so if 1C, then for the current node, of course, this is the intra-routing. So we will allow the packet to go to pole or interface 1. All right, and to X. Destination to X, not in the current one. Actually, we have the past advertisement, so we know. All right, so we should go to AS3. To AS3, so of course we should have the interface 1 from the current router 1D. Because once we reach 1C, then we can go to AS3. And likewise for 1C, currently maybe you have a question why we choose 2. Actually, for some reason, maybe we have a decision go to interface 2 rather than 1. So this one we don't have the specific reason, but we just don't know, maybe based on some way we determine to go to interface 2 for 1A. And likewise, because we can go to C using interface 2, so likewise X using interface 2 for router 1A. And in fact, we can have 1C, and so that 1C maybe we have an interface here, or okay, it's 1 or it's 2. If we want to reach X, then we can allow the packet using interface 1, but we don't mention that one. At least you should understand if we have the path advertisement, then we will have some setting for the output interface. All right, and about intra and inter-AS routing. Specifically for inter, we mention policy. All right, so if it's the intra-AS, we just have the unified single administration. That says it won't be important to consider any policy. So we have the description, policy less of an issue. That says it won't be an issue. Therefore, in the discussion of intra-AS, actually, we don't care about policy. However, for policy in the inter-AS routing, we don't have the same ISP. So of course, we have the different ISP, and then we can set the policy for the ISP. And because of multiple ISP coexist, so we should consider policy. All right. So the first discussion actually that we know, we have a policy for inter-AS. we don't have the policy consideration for intra-AS. Of course, intra and inter. Why we want to have intra and inter? In fact, we consider scale or not. That says we consider the factor of scalability. So we consider the scalability for the second issue, scale or not. And if so, then we can pass on the hierarchy. And so that we have the hierarchical routing. And we won't have a large table because of the arrangement of intra and inter AS routing. So we can reduce the updated traffic for sure. Well, and we have the reason, scalability, to have intra and inter initially. And because of inter and intra, so we will consider the policy or not. And about the performance, intra-AS actually, it care about the performance. So it's correct. For intra, we care about the performance. However, for inter, we consider the revenue. Therefore, we still care about policy to make money, to care about making money. So intra, we care about policy. However, for inter, we care about policy, and intra, yes, we care about performance. So inter for policy and intra for performance. And actually, the reason here is scalability. So we have the intra-inter to work together. Well, and in fact, in the past, we have the single hub routing. And this one also consider the single hub routing. So we call it the hot potato routing. Hot potato routing just consider a single hub. Why? That we have the hot potato. It's really hard, so we need to consider which one to pass immediately. So we have the specific term hot potato routing. Actually, it just consider the next hop. Well, next hop, and using the term hot potato routing, and you can think about this one. So we have the advertisement prefix arrive from S1 to S. So we have many prefix, maybe not too many. At least we have the network prefix for advertisement and 2D here. All right, via IBGP, right? Because internal, not external. Via IBGP, it can have the route to X. For some reason, we know, oh, we have a 2A, we have a 2C. Maybe for some reason, we have a 2A and 2C to X here. Even initially, 2D don't know, in fact, near the autonomous system 3. And hot potato routing here, we just choose one. And choose local gateway that has the least intra-domain cost. So that says hot potato consider the intra-domain cost. Something like we want to determine which one you want to use. So we can pass on the next hop. And the hot potato actually care about gateway. Alright, so it doesn't mean the real next hop, but at least here it's the next hop, and the next hop here to reach the gateway. And pass on the gateway, and then we will know, okay, which one we prefer. So it doesn't mean we consider the whole cost, including the inter-domain cost. We just care about the local cost to the local gateway. And 2A and 2C, finally, which one we want to use? Here, we try to have the cost 201 and 263. So which one we prefer? Actually, we think this one. So even network prefix AS1 to AS3 may be the actual AS. However, because of the hot potato routing, still we choose 2A and 2A. Possibly we'll choose AS1 to send the packet to X. So we have the hot potato routing for the local cost to choose the gateway. Well, again, here we have the discussion about the policy. Actually, we try to, I don't know, we may have many ISPs, A, B, C. So here you see this one, ISP. So we have a ABC, and then, okay, we have multiple ABC, then possibly it doesn't mean all the paths can be used. So that's why, because of a policy and policy to have the following advertisement. Well, A, actually, we are seeing go to W, we will have an advertisement. Okay, through A, we can reach W. All right, no problem. And maybe for the reason of policy, B choose not to advise BAW to C for the reason of the policy. And if so, then C won't have the CWA to W path. All right, so here we just want to mention, because of a policy, sometimes we cannot have some possible path. Even it's viable, but because of the policy, we cannot have that path. So for the current one, we have a story like this. B does not choose to advertise the path to W to C. All right, so currently A, B, C, you know, they are ISPs. And X, Y, and W, you know, they are customers. And furthermore, we have a term, dual home. We just want to let you know the term, dual home. Dual home here means the current node can attach to two ISPs. If so, then we have the term, dual home. All right, and once we have the dual home, then we can consider this one. X does not want to route from B to C. Okay, so that says from B to C for X. So we may have some preference, and so that we can have some setting. Well, all right, maybe you can check the slides later. I don't know, yeah, for some reason, so that we can have some policy to enforce. For example, this reason. And so that this kind of reason, then we will have some corresponding setting. And these settings are related to policy. So if possible, then we will have the suitable setting by considering the policy chosen. All right, so this is the summarize serving as the review for BGP rule selection and what we can do. All right, so we can consider policy. Of course, normally we will choose the prefix and so that we have the shortest AS path. However, if we further consider policy, maybe not the shortest one, but normally we will choose the shortest AS prefix or here AS path. And possibly we may have hot potato routing. If in an AS and currently we want to choose the gateway, then we will have those. And actually for the previous page, somewhere like we have this one. Oh, maybe for some additional criteria, we should have some different setting. Then they are possible. And so that we can have the way to choose the rule for under BGP. So here we already have the variable consideration, and so that we can have the route selection for BGP. All right, that's all. So we finished the discussion for BGP, and actually we based on advertisement, and we didn't know the reason why advertisement as well. And currently we reach attendance checking, so let me check the path for you. So maybe I just use 3 girls in the classroom, 1 there. So 1 and 2. Maybe you join 2. And 3 there. So we have 3 groups only. If you want to correct, that's fine. Or maybe you don't want to do that, that's fine. Later, for the TPS, we will use the setting group 1, 2, and 3. All right, so times are a thing. Even for students online, you should finish it. So let me go to the next one. This one. I will ask you to think about the advanced routing. Advanced routing talking about inter-AS routing. Therefore, we have this. We have OSPF, we have a BGP. And of course, OSPF is one of the intra-routing protocols. And BGP is one of the inter-AS routing protocol. So I ask you to think about the 2 types of routing protocol, advanced routing algorithm protocols, and currently about your comprehension. So, understood well, or maybe something need to ask me to re-explain. So we have this. Okay, this time it's okay. This one, again, 2 minutes for you to finish it. Well, up to now, it seems to be okay. Some of you let me know, understood well, that's fine. Maybe some of you, okay, understood, but it doesn't mean understood well. That's fine. All right. Still allow you to have 30 seconds. Okay, so let me move on to the next activity. All right, so this one, thin pair share the current problem. First of all, take a picture for students online or students in the classroom, and later I will that you have the QR code to scan. However, at least have a picture for the current TPS, and so that you can have the discussion. We have 3 groups in the classroom, 1, 2, and 3. For students online, I think you have your own way. Well, if I ask you to reach the Padlet here, this is a QR code, and let me scan, let me pass the link to our line group as well. Wait a moment. So this is the TPS arranged for Monday, but we perform this today. So this one. You have 5 minutes to discuss with your neighbors, and later if anyone wants to share, go ahead. If you consider to serve as the presenter, you can upload your answer first. Of course, later maybe you have your own reason. Therefore, if you can have the short reason, you can provide the short reason. Alright, so let me check. Anyone want to serve as a presenter? Good one. No. And good two? And good three? Oh, maybe let me try to split the problem into A and B. Who want to share the idea for subproblem A and B? And who want to share C and D? If A and B only, and then? Or maybe you can take the whole problem to share. Well, seems to be you need to have more time. That you have 2 more minutes. A and B. A and B. And of course, you should update your answer after classes. So, upload your answer for reference first. Alright, so currently we have A and B and shared by Deborah for your reference. Alright, maybe I show the answer from Deborah. So for your reference, sure, Deborah, we're gonna choose her to have for the presentation. But Quentin, it's you, right? So, right now you can share your answer here. So wait a moment. Alright, so your turn. You try to use mouse to scroll the answer.
Okay, so for the question A, router 3C is inside IS3, which use OSPF internally, but prefix X comes from IS4, so it travels through BHB first, and IS4 sends X to IS2 using eBGP, then IS2 passes it internally with IBGP, then IS2 send it to IS3 using eBGP at the border. Once it's inside IS3, the prefix gets shared around using IBGP, no OSPF. So yeah, 3C learns prefix X via IBGP. And for the question B, it's the same logic. router 3A is also in A3, so the logic is the same. The prefix X enters A3 through an EBGP session with IS2, and then IS3 distributes the truths inside the IS using IBGP. So 3O also learns X via IBGP.
Okay, so for your reference, it doesn't problem. Okay, thank you. So Quentin provide the answer IBGP for A and B. Correct? Now I'm not sure. This one, the answer of Deborah A says E and B says I. So we have the different answer. Because of the discussion, so allow you to think further. And likewise for the problem here, allow you to update your answer before 4 p.m. Alright, so this is a sharing for subproblem A and B. So anyone want to share your idea for subproblem C and D? So Quentin, if you can have the update, you show your status. Presenter. Okay. And of course, you need to update your answer later for the whole problem, right? So anyone want to share your answer about subproblem C and D? You and upload your answer. Okay. All right. So then you use mouse and so that you can have discussion. Come.
Okay, so for the question C and D, we know that the advertisement is conducted under the protocol BGP. Okay, so I just default the answer will all be BGP, and afterward you will find that for the C, which is from 1C, yeah. So the 1C will get its advertisement from 3A. So I consider it to be the eBGP because it's inter-AS. Yeah, okay. And then for the questions D, 1D is inside the AS1, so you will get the advertisement from other intra protocols, other protocols in the same AS. So it will be served as an intra-AS. So the answer will be IBGP. Yeah, that's my answer.
Okay, thank you. So let me have the quick checking with the result from Deborah. Deborah says eBGP for D, a C, and actually it should be I, but Deborah, it doesn't indicate I or E. All right, so right, according to the description, it seems to be says, oh, no, it says IP. Oh, IP or not, I'm not sure, but D not the same. And you can check the others for your reference, but at least this is the TPS. We have two presenters, share subproblem A, B, and share the answer for subproblem C and D. All right, that's all. I think maybe some of you still want to have the further consideration. Same, we allow you to have the updated answer before 4 p.m. today. All right, and for the presenter, you can have the information. You are the presenter, so Huei-Wen, right? Show your status, presenter, and Quentin, show you are one of the presenter. All right. If no, maybe I will have the note to TA so that they can have the notice presenter. For presenter, we always have 2 points of bonus. And this one I treat it once, so we have 5 points for the current TPS. All right, so we have some answer. I will release a solution later, but we still allow you to have time. So I skip the answer and pause the answer after 4 p.m. to all of you using our line group to notify all of you of the solutions. All right, so this is the TPS. So after the TPS, maybe you still have a few minutes. Let me move on to the next one. So previously, maybe I stay in the thinking mode. Actually, I should switch to the demo mode. But let me get back to the lecturing mode. Lecturing mode, we talk about SDN control plane. You know, SDN, some of the information known in previously. We have SDN here. All right. And in the following, we don't know using the monolithic way. That says according to time, we will have switching hardware and run proprietary implementation of Internet standard protocol. For example, IP, ISIS means OSPF, and actually they are not the same. Similar to OSPF and BGP. All right, this is the initial way, and of course later we will have some middle buses. All right, including firewalls, load balancers, NAT buses, etc. And so that we will think about if we have all these, we have some software consideration. So we will think about how to have the network control plane. Of course, we will already have SDN. All right, and this one for your reference. We have a lot about the control plane. Initially, the traditional one is a per router control plane based on the router. So this one I think you know, and I go through quickly. Allow the router to have the setting of the forwarding table. All right, so this is a traditional one, not SDN. But for SDN, in fact, we have the remote controllers. Here, we have remote controllers. And then, similar to the previous one, but we perform the updating for the table using the remote controller. So, remote controller, something like we have a copy of the table in the remote controller. Of course, we will have the update through the agent, control agent, and the control agent can set the routing table for the routers. I think all of those you've known previously, and I just go through quickly. And why we want to have the logically centralized control plane. Here, we want to say this again. We have many ones. Hardware, software, of course, we want to have a control. If we want to use the viewpoint of control, of course, we need to have the centralized, maybe the server or something like the controller. So because of that, we expect this. If we expect this, well, we can have the proper control for sure. Even not faster, but if we can do that, of course, we prefer that one. And so that we can control possible entities. Well, so from the network management viewpoint, it says will be easier. All right, will be easier because we can have the possible correction. If a correction, then we can avoid misconfiguration. So we have the flexibility if we have the centralized one. And furthermore, emphasize centralized one, it will be easier. Distributed one, even in the past, we prefer the feature of distributed one, but it is more difficult to implement. And so that if we have, in the past, we have proprietary implementation. Right now, if it is open, then we prefer the open implementation of a control plane. Because of that one, then we will enable SDN. All right. Okay, so I stop here and let me summarize the content discussed today. Actually, we finished almost half of the BGP and that we have 1 TPS. Because of a bit more time, so we start the discussion for SDN, and we will continue SDN next Monday. And next Wednesday, we will have a quiz number 3. All right, so this is the content discussed today. And before you go, let me measure any questions. If no, see you next week. Bye-bye.